Okay, so in this video we are going to look at how to analyze using Gephi a directed network where you have a network of countries that contract their players to play for other countries. So country A may be contracting its player to play for another country, okay, or probably a citizen of one country to play for another country. So something like that. Okay, so this is the network for the soccer. I think it was 98 World Cup. Yes, soccer 98 World Cup, and we have citizens or players of one country being contracted to play for another country. So we have like 35 countries listed here, and these are the labels of these countries, and these are the edges connecting these countries. So basically this indicates country 1 contracted 4 players to country 12, country 2 contracted 7 players to country 10, and so on. Okay, so I'm going to copy the list of countries. So you're going to see how to, okay, first of all, how to get this information. Just go to Google and search for soccer World Cup 98 network data, something like that. You should get let's see, you can also say this is sort of paycheck. Yeah, so this data was originally collected for Paycheck and being used. Paycheck is another network visualization software like Gephi. Okay, so if you click like that, you should get it, and go to complete data set. That should give you this. Okay, so I'm going to copy this, go to Excel, and just paste it as it is. And now actually the whole thing is selected because everything is in one column. So we can go to data and separate into columns based on space as the delimiter, and we can get rid of these entries. Okay, and we don't need this. So now we'll make it like this is the node ID and this is the label, the countries. I already have one, so let me create a duplicate. So this is your node set. Actually, I should save it as, I made a mistake. I should save it as a CSV file. So let me go and make it as a CSV file. And don't worry about any loss in format. Let's say S. Okay, yes. Okay, let me go and delete this one, which I don't need it. Okay, so this is my CSV file for node set. Now let me use the edges, copy the edges. Okay, this is a small graph, so we can copy and paste it. Even for like larger graphs, it should be just easy to copy and paste. So let's just split it into columns. Okay, so this is for Gephi. You should label the edges like from source to target. This is your weight. Okay, so these names are kind of built in, so we'll make sure to label it as a CSV file. So soccer, again you could name the file anything you want. So let's go to Gephi. Okay, this is something else I was doing, so let me, okay, right, so let's say new project. I should be able to open, no, you're going to load the thing from this, right? So let's go to data laboratory, make sure you click on nodes, and now import spreadsheet. Make sure you select nodes table, and now go back to link that you created, the folder. Make sure you load the nodes table. These are your nodes, and you want to I thought we can make the ID as an integer, but it is built in, so let it stay as string. Okay, so these are your IDs and labels and the nodes. Now let's go to edges, import the edge spreadsheet. Now you see here, if you just make the change to edge table, but we have node set listed there, it's not listing the source and target, so that's why it's complaining. So let's make sure you select the edge set. Now you see source and target, so it's not complaining. So now you'll have the option, yeah, so weight is float, so it found out weight to be float. It's the number of players who are contracted. It should be an integer, but it's not letting, let me see, it's not letting us to change it, so let it be okay. Float is not a problem. So now if you go to overview, you could really see this. Okay, now you could make it a little bigger. And at the edges. Okay, let's go to global and make it, okay, so this is making it big enough. Okay, and if you place your cursors anywhere, it's not showing what the node is, because I have not selected the label option. So click on the label. Once you click on the label, you see each node is being labeled with the country. And this is a directed graph, because one country can basically contract its player to play for another country, but the other country need not contract its player to play for this country. Okay, now you see that some edges are thick and some edges are thin. That's because you have weights for the edges, so the edges that have more weights are actually more thicker. So let's look at this. GBR is getting players to play from these other countries. Okay, it could actually give out some players to play for other countries. Okay, so this, when you place your mouse over here, it shows both types of edges. That's why I go to the data laboratory to see the edges. We haven't calculated the degree, so let's go back and calculate the degree. So if you run degree, computes the average degree of the vertices. It also gives you the in degree distribution and the out degree distribution. So let's go back now to the data laboratory, and for the nodes you should be able to see the in degree and out degree. And the way Gephi does it is, for the overall degree, it adds up the in degree and out degree, which I don't think is a good measure to do. It's a good way to do it. It's not a good way to do it. Okay, so you should just stay, for directed graphs like this, you should just stay with in degree and out degree. Okay, let's now you see here, this could be a total. If you add up the degrees, you think the total degree is 19, and Italy node 18 has larger degree, but that's not the case. Okay, so it's better to just leave it like this, as in degree and out degree. Now let's go and also compute our clustering coefficient, but this is a directed graph, so it's not that informative to compute clustering coefficient. Let's compute the hubs and authority score. That will be useful. Okay, so these are your scores for the hub and authority parameters for your nodes. So what they essentially indicate is these many nodes have a certain hub value. The hub values are not that easy to find out from here, but you can go to the data laboratory and find out the hub values and authority scores. So if you click on authority, this is in the increasing order. If you click like this, it shows you in decreasing order, which means node 12, which is Spain, has the highest authority score. So authority score is when several other people are pointing towards you, right? So because you see also is in degrees quite high, so in degrees proportional to the authority, and or is kind of related to authority positively, whereas out degree is quite low for Spain because it's not giving much out. Okay, but sometimes it could be a combination of both. That's a very good node that is also authority as well as a hub. Okay, so this is the hub scores of the nodes in decreasing order. Okay, so Italy has the largest value for the hub. Okay, Spain had its largest value for the authority. Okay, so let's go and plot the graph with using the hub score and authority scores. So you could use your color as the authority score, it doesn't matter, and you can say apply, and you can go now to the size and say as hub. Actually hub is more authority is more important, right? So let's make the hub as for the color, and let's go to node size and choose authority. Okay, so you see here if you zoom it, zoom level is only like two different things. Okay, that's fine. See here, this guy is very dark. So dark guys means it has a larger hub score, right? Because it shows color for hubs, and darker is better, and lighter is actually lower hub score. But the circle area, the larger the circle area, the larger the authority score. So the outer one, the larger circle area, but has the lowest hub score because it's kind of white. But this is good. This guy is comparatively actually larger. Okay, it's comparable, as well as it is a good hub. So let's go and see what is that. Let's go back to the overview. So it's this Italy. Italy has a reasonably good authority score, and it's also a hub. Okay, so if you place your cursor here, it shows you the edges. Now you see, this is interesting. It's basically it's, if you make the edges a little bit bigger, okay, okay, so you see here for Italy, it's essentially, it's a hub, right? It's a good hub because it's pointing to a good authority guy. So Spain is essentially this, France is also here. So let's see if we can have a better layout. See, this is the usefulness of the layout algorithm. So my previous setup, I was not able to easily visualize it. Now I ran the Fletcher-Mandarin Gold layout algorithm, and it gave me this. So this is my Italy, right? So Italy is pointing to Spain, which is a very good authority node, and Spain is basically having a good authority score because it is pointed to by a good this guy is good authority as well as a good hub, right? Italy. Let's look at this guy. I'm wondering why these edges are not visible. Let's make the edges a little bit more bigger. Let's make the edges colored. Okay, so you see all the countries that are visible are connected to Spain. That's why it has a good high authority score. But somehow the edges are not that visible. I think, yeah, because we're using color as the okay, I understand. So we are using color for the edges. So you can also have once you have weights for your edges, Gephi automatically colors them. So the edges that have light weight have a lower weight has a light color. The edges that have a higher weight have a higher color. So you can go to this edges and see this. We can don't think we can disable the coloring of the edges. Let me try it here. I don't think we can do that. If we can make this all edges, okay. I don't think still edges are colored based on their weight. Okay, this will only color them like this. Okay, so that's still okay. So you can still see what are the countries. You see all these countries like Brazil, ZAF, Romania, and all these countries are having edges to Spain. Okay, more likely you see, as you see here, Yugoslavia is sending more players to Spain or contracting. So several edges are kind of you see all those incoming edges. So this is why it's a good authority. We have incoming edges from like 1, 2, 3, 4, about 7, more than 7 vertices. Italy is also a good authority because it is pointed to, you see, by good authority scores vertices, but also it's a good hub. It sends out players to all the other vertices you have here. Okay, you have highlighted here that shows highlighted. Italy is sending out its players to them. Okay, so if you center, this option lets you to center your graph. So if you now click on Italy, you can click on Italy and see now these are the vertices that are sending out the players, and the other ones are to those to whom Italy is sending out its own players. So that's why it's a good hub. But still, it doesn't send it to all the countries out there. There are some countries that are not visible, and you cannot see those things here. Okay. Alright, so now, so we saw the layout, we saw the ranking, hub authority scores. Okay, so we basically plotted here the hub versus authority, the hub for the color of the vertices and authority for the size of the vertices. Okay, so Italy is relatively darker as well as the size of the node is larger. Okay, So this graph shows you that. Okay, so the larger weight for the edges indicates more a country is sending more players to play for the other country. Okay. Now, like we did for, I think we did in SciNet, or in the previous video, we had one measure that we computed in SciNet and we loaded it up in Gephi. So let's do something like that. So we already analyzed this soccer network in SciNet, and I can show you again how to do that. So let's go to measures. So this soccer network, or actually go to network analysis, click on new analysis. So you can name it anything you want. So I'm just going to say this, we are going to analyze the betweenness centrality, and so we have to pick up the network. So let's go and pick up the network we want. It will be somewhere down, but I'm going to just see all of them and then go and, okay, this is my soccer network. And then measures, I'm going to just measure the betweenness. You can pick anything else also. This is a directed graph, so let's see what else we can pick. I think betweenness is good enough. Okay, so let's go and run the analysis. I just want to show how to find get the values for one metric like betweenness here, which Gephi cannot find it, and then you can load those values to Gephi and also visualize it. Okay, so let's analyze this. Okay, so it is computing the values. Okay, it's done. So now let's look at the values. So these are the values for Gephi. Sorry, the betweenness centrality. It's not sorted in any order. So what I'm going to do this is let it stay here. Let me go to Gephi. Now this is my current set of this is my node set and this is my edge set. Okay, I'm going to export the node set because the edge set could be as it is, that's fine, but I'm going to export my node set to as a CSV file, okay, to this, because I'm going to now load that node set in Excel and then add the betweenness values for the vertices. So that's what I'm going to do. So it has been exported with success. So now let's go to Excel and open the new revised set, because it's all clubbed together like this, but just select the first column, which means you have selected everything, then break it into columns and it shows the different things you can done. Now so let's add our betweenness values. So I'm going to say betweenness centrality, or just say betweenness, that's good enough, betweenness centrality, and I'm going to now get the values from SciNet. Now you see here, this is the order in which you have, these are like randomly, this is for node 24, the betweenness node 10, this is the betweenness, so you have to be careful here. Here the nodes are listed in increasing order 1, 2 and 3 and so on. So what we should do is, let it stay like this. Let me temporarily copy those betweenness values to a separate Excel file. Okay, So I'm going to put it here and then break it into columns. Now sort this first column, which is the node ID, based on the ID. So I'm going to sort it in increasing order. So now you have the betweenness values or vertices in the order of the node IDs. So now I can copy this and go to this spreadsheet and I can paste it. So these are my betweenness values. So now save this still as a CSV file. So say S, and then this will be still S, say S. So now let's go back to Gephi and import the spreadsheet. Make sure you select notes table, import the revised one. So you have now the betweenness. Since you added the betweenness newly from an outside source, you could set its data type. So you could say it is float, and then you can finish this. So this is our new dot betweenness. Let's see, values should be listed here. Okay, it's showing up. So let me reduce it so that I can start seeing this. Yeah, let's move it so you can even move things. Okay, so you can see all the columns. Okay, since you made it as float, it does take some space. If you make it like this, it will be okay. Right? Okay, so now we have betweenness centralities of all the vertices. Now one thing that you can notice is the IDs get messed up. The node IDs get messed up. This because yeah, so it's better to, once you modify your CSV file, it's better to close the whole thing as a project. Let's close the whole thing as a project. We did not save it. So let's now open fresh, go to data laboratory and go back. Let's make it new project first of all. So once you make it new project, you have the options to upload your notes. So now you can upload your notes set. I think I can still select it to be float. That shouldn't be a problem. Okay, so these are your vertices. Now you have the IDs from 1 through 35. Let's go back the edges and import the edge set, which is of no change. Okay, these are your edges, vertices. So now you can go back to overview. It's the same graph that we saw already. So let's run some layout algorithm and see if we can have a better view. Okay, actually I am in edges, so that's why if I move left, the thickness of the edges reduces. If you move right on the edges panel, the thickness increases. But on the global side, if you move to the left, it kind of becomes bigger. So it's kind of opposite way. One way for global, one way for edges. Okay, so this is your layout. Again, the edges, the weight, the thickness of the edges are based on the weights, the number of players who are basically being contracted to the other country. So now let's go back and rank the vertices, or kind of make the vertices more visible in terms of the ranking based on, we had betweenness centrality newly added. So let's try to do that. You incorporate that. We don't need to calculate it because it's already in the data laboratory. We can run for the degree, and this is again the degree distribution. So we need to run that measure before we use it. So let's go and use the size. Basically, let's make it centrality as the size. Okay, so Spain, which has highest centrality, is essentially, now you can see Spain more clearly, all the edges, incoming edges, because it's also a good authority guy, right? Okay, and let's color the graph based on the degree. Let's make it based on the data laboratory has in degree, right? This in degree same as this in degree, so just the hyphen is different. Okay, so let's select in degree. Okay, Spain, which has high in degree, is also having high betweenness centrality, and so node having high degree is more likely to have good betweenness centrality also. But let's see if there are some darker node. Let's refresh it. So anything else more darker? This is darker relatively, but has little less betweenness centrality. I don't see anything which is darker in the periphery, which means it has high degree but low betweenness centrality. No. So vertices that are in the central core have high degree, and they're also having high betweenness centrality. So you can see here in this particular example or comparison, the degree and betweenness centrality go together most likely, right? Okay, the in degree especially and betweenness centrality go together. Let's go back and see if you can get the same without degree. Need not be, that's why, because you see Spain has more in degree but less out degree. So if I refresh it, you can see darker color. This has more out degree, that's like a more hub node, but it has low betweenness centrality. So outgoing degrees, outgoing edges need not contribute much for betweenness centrality, whereas incoming edges contribute more for degreenness centrality. So this is something very interesting to find in a directed graph like this, that in degree is kind of positively related to betweenness centrality, whereas out degree is not that positively related to betweenness centrality. Okay, so okay, you can see here, so this is a country that has high betweenness centrality because the circle for the node is quite larger or bigger, whereas this guy is having high out degree because it is the darkest of all, but it has relatively low betweenness centrality. Okay, so we'll stop with this.